Hey there, friend. Welcome to another episode of in this interview series. In this series, we go through various interview problems that you're likely to encounter as a programmer. I want you to pass this interview. That's why I'm making these videos. In today's video specifically, we'll go through palindrome. Now, a palindrome is something that reads the same whether you read it from left to right or right to left. For example, were you to read 1-to-1 from left, you would read it as 1-to-1. If you read it from the right side, it's also 1-to-1. That's great. But what is not a palindrome? Well, if you have the number 1 to 3, if you read that from the left, it becomes 1 to 3. But if you read it from the right, it becomes 3-to-1. Now, 3-to-1 is different from 1 to 3. That's why it's not a palindrome. To solve this task, we need to break it down into various sub-problems. And by conquering each of these sub-problems, we will arrive at a solution that hopefully checks out. As with every interview problem, it's important to communicate with your interviewer. Tell them what you assume, what you don't assume. If you speak out loud, if you think out loud, you will be able to get corrections from your interviewer. For example, if you make an assumption that's not correct. They don't want you to fail. In fact, they want you to succeed. Now, first off, what is the first sub-problem? Well, for one, because we're looking at it from the left side and the right side, we will need to have some kind of looping construct because we need to be able to loop from the left to the right side. We also need to be able to loop from the right side to the left side, and we need to do that at the same time. For this to be possible, we need to take this number and turn it into an array. By turning it into an array, we will be able to traverse each and every item in that array. So for that to be possible in Python, we need to turn whatever number we have into a string. So if we look at this first code line, there's a way for us to do just that. We can take our value with a string function. We can turn that into string. That's great. That means we have somewhat conquered subproblem 1. And next, we need to turn that into a list. Now that we have it in a string form, we can use the list operation to turn it into a list. So first off, it's a string. And now we take that string and turn it into a list. Thereby, we have solved subproblems 1 and 2. The next problem that we need to address is to define where to stop looping. Now, if we look at this as, well, not coders, if we look at this problem, if we have, for example, 1, 2, 2, 1, or 1, 2, 3, 4, we need a way to say stop, that we've actually failed. And we might, if you look at this number, if we compare 1 versus 4, we might see already there that we need to stop because these numbers are not equal, right? But if we have something that's actually palindrome, we would compare the 1 to the 1 and the 2 versus the 2, but at some point we need to stop, and that stopping point is actually in the middle. So we need to find that middle point for our number. So let's say, for example, 3 here. We would need to stop here. For us to be able to find that middle point, this is what we would do. We would take the length of our string, we would divide that into 2, and then we would use the math floor operation and round downwards, right? So if we have 2.5, that would become a 2, for example. So we want that to be an even number. So now we've defined our middle point where we should stop iterating. But as I said before, we might stop iterating before that if we notice that the numbers don't add up. The next thing we need to do is the iteration itself. And there's one thing I want to say about the iteration, and that's that we need to be able to compare the actual values, but we also need to know what index we're on so that we can say, for example, hey, we've gone as far as we should go, we've reached that stopping point, and it's time for us to stop iterating. The next step is thereby to say, hey, if my current index that I'm on while iterating hits that middle point, then it's time to break. Our next point of interest is to say, well, there is actually another condition where we would say, okay, stop iterating, but not only stop iterating, say this is clearly not a palindrome. And if you look at line 23 here, we are expressing just that. So what are we saying? Well, what we are saying is that we're looking at the current index. That means we're looking on the left side of things, and we're comparing this towards the right side. When we start out, index has the value 0, and thereby it's 0 over here, and we are comparing length minus 1. So we are comparing this one towards this one. And as we progress in the loop, the index value will increase, and it will increase here too, which means that we will move further from the right to the left side, which means that if we have a much longer number like so, it will start here, and then it will progressively go to here and compare this one to this one, and then it will stop here. So it's this is probably the most tricky part about this answer, is to figure out how to express this and realize that, well, how do we define us moving from right to the left? Well, we kind of need to move from the right to the left at the same pace as we are moving from left to right. So once we have that, we probably have a working function, and the reason for uncommenting the return true here is if we in no cases have encountered a situation where these two numbers don't line up, then we can safely say, well, this seems to be a palindrome. So let's have a look at the test cases. First off, we're sending in 1 to 1. This should be a palindrome because it reads the same from left to right. 12, however, reads 12 from the left to the right side, but it reads as 21 from the right side, which is not a palindrome. And 1221 is definitely a palindrome. And if you look at the last case, this is also 1221, but in this case we are sending in a string. Let's see what happens. Here we're getting the answers that correctly 1 to 1 is a palindrome, 12 is not a palindrome, 1221 is a palindrome, and we can see that it's able to handle the fact that it's being sent a string, because if you look at the way the function does things, it's converting something into a string already, right? So this doesn't really matter if we send in a number or a string version of that number. So I want you to check out this problem, but most of all, remember to divide it up into subproblem, communicate the subproblems, and communicate any assumptions that you make, because your interviewer might ask you to do something with this. They might say, for example, well, if you feed in empty string, or if you feed in something else that should make the function break, how would you handle that? So that's something to consider, that your interviewer might not only be happy with you implementing a correct solution, but also that you communicate and that you're able to take new requirements and implement those, and again communicate through that whole process. That's it. That's all I had for this video, and hopefully you feel like, okay, if someone gives me a palindrome problem, I'm going to remember what Chris said, I'm going to divide this up into subproblems, I'm going to communicate, and I'm going to arrive with a solution that checks out, but more importantly than not, the interviewer understands that I know programming, I know syntax, and I know how to stepwise get there. Thank you for listening. If you appreciate videos like this, I would much appreciate a like or a comment, or even a subscribe if you're in that mood. So thank you for listening.